Okay, continuing on in trigonometry. The task today is to help you be prepared to finish this entire table that's in your notes. That's going to be the first lesson, that's going to be the first grade you're going to earn, is to send me a picture of this page once it's completed. And once everyone has done that, then I will upload the key and you can check things over. This is very, very small, so I'm going to do a few of the rows. I will lead you through this. I'm going to do the rows on this sheet, rows 1 through 6. I'll do all of those, start to finish, all the way across. And then we'll jump to row 10, 14, 21, 25, and 26. And that should give you a pretty good idea how to approach these problems. And you can ask me during conference hours, office hours, every morning, Monday through Thursday, if you run into snags with any of these, because it's not always easy. Once you get the hang of it, though, it's pretty straightforward. So, reminder that it's expected that you know your automatics, that the sine, cosine, and tangent of 30, 45, and 60 are all memorized, and that will make life a lot easier. So I'm going to actually start by doing rows 2, 3, and 4 here. These are the automatics. Let's fill in row 2, we have pi over 6 radians, that's equivalent to 30 degrees. And then the sine of 30, that's going to be one of your memorized values, it's 1/2. The cosine, square root of 3 over 2. And the tangent is square root of 3 over 3. Okay? Memorized. Now, let's go, we'll do the rest of it, we'll do these other columns later. Let's do 45 and then 60, okay? 45 degrees is the same as pi over 4 radians. The sine of pi over 4 is square root of 2 over 2. The cosine is also square root of 2 over 2, and the tangent is 1. Again, these are just supposed to be memorized, okay? You're not figuring these out as you go, they're memorized. Row 4, pi over 3 is the same as 60 degrees. The sine of 60, square root of 3 over 2. The cosine, 1/2. And tangent, the square root of 3 over 3. These are your automatics. So I'm going to outline those as the ones that are supposed to be memorized. Okay? And all you got to do, and you're never going to be asked to memorize these in my class, the cosecant, to figure out what goes in this column, all you got to do is realize that the cosecant is the reciprocal of the sine, and the secant is the reciprocal of the cosine, and the cotangent is the reciprocal of the tangent. So if the tangent is y over x, the cotangent is x over y, or since remember y is the sine, and x is the cosine. Tangent is y over x, cotangent is x over y. So to fill out the last 3 columns, all you gotta do is flip these over. So if the sine of an angle is 1/2, the cosecant is the reciprocal of the sine. It's just flipping that fraction over, you just get 2. The reciprocal of the square root of 3 over 2 is 2 over the square root of 3, but then you gotta rationalize that. That ends up being, if you do, I'll do it down here, 2 over the square root of 3. You got to rationalize that by multiplying top and bottom by the square root of 3. You get 2 square roots of 3 over 3. And the reciprocal of the square root of 3 over 3 is, if you flip it over, 3 over the square root of 3, and then you rationalize that. 3 square roots of 3 over 3, and then the 3's reduced, you just get the square root of 3. Okay? Do that with these. We flip over the square root of 2 over 2, you get 2 over the square root of 2, which becomes 2 square roots of 2 over 2, and the square roots of 2's cancel, you end up with just the square root of 2. Same thing there. And the reciprocal of 1 is 1. We already did these. The square root of 3 over 2, when you flip it over, becomes 2 square roots of 3 over 3. The reciprocal of 1/2 is 2. The reciprocal of the square root of 3 is 1 over the square root of 3, and then you rationalize it by multiplying by the square root of 3 over the square root of 3, and you get the square root of 3 over 3. Okay? So, as you know, if you flipped this over, you got that. Flip this over, you get the other one. So square root of 3 over 3. Okay? Now, for the 0 degrees and 90, these are not part of what are the automatics. For these, I just recommend that you memorize the position around the unit circle, because remember that the cosine of the angle is just the y-coordinate of that point. Or I'm sorry, I said that wrong. The cosine of that angle is the x-coordinate of that point, and the sine of that angle is the y-coordinate of that point, as explained in last week's notes. So, for things that are right on the axes, at 0 or 90, 180, 270, okay, any of those, since this is the unit circle and has a radius of 1, this is super easy. The point over here at 0 degrees is the point 1, 0. The x-coordinate of that point is 1, the y-coordinate is 0. And since the x-coordinate is the cosine of 0 is 1. The sine is 0. That's all you got to do for the ones that are on the axes. So, if that becomes super easy here. So, for 0 degrees, that's also 0 radians. The sine at 0 degrees is the y-coordinate of that point, which was 0. The cosine is the x-coordinate of that point, which is 1. The tangent is y over x, 0 divided by 1 in this case, which is 0. Now, the cosecant is the reciprocal of the sine. What's the reciprocal of 0? 1 over 0, which is undefined. I'll just use the empty set for that. Or you can write a u if you want. Some people prefer a u for undefined, but either one's fine. Secant is the reciprocal of the cosine. 1 over 1 is 1. And the cotangent is the reciprocal of the tangent. 1 over 0, that's undefined again. Okay? So 90 degrees. Now we're at the top of the unit circle. The coordinates are 0, 1. First of all, in radians, that's pi over 2. And the sine at 90 is a positive 1. That's the y-coordinate at that point, 0, 1. The cosine is 0. The tangent is y over x, or sine over cosine, 1 over 0. That's undefined. The cosecant, the reciprocal of the sine, 1 over 1 is 1. The secant is the reciprocal of the cosine, 1 over 0, that's undefined. And the cotangent is the reciprocal of the tangent. What's the reciprocal of undefined? Well, how did we get that undefined? It was 1 over 0. So if you think about that fraction 1 over 0 and you flip that over, you get 0 over 1. That's 0. Okay? So the ones that are on the axes, 0, 90, 180, 270, 360, just picture the point and locate, the coordinates of that point. Up here, it's 0, 1. Over here, it's negative 1, 0. Down here, it's 0, negative 1. And you can get your sine, cosine, tangents pretty easily from just picturing the coordinates of those points. All right, so then, if we branch out into a couple different angles, like row 6, 120 degrees. Okay, well, 120 degrees, if we start, here's 0. Okay, 0 is to the right on the x-axis. Here's 90. 30 degrees past that is 120, somewhere in here. So this is the angle that's 120 degrees. But all we're concerned with, all we really need to know is what family it's part of. And the family it's part of is basically the angle it makes with respect to the x-axis. If this is 120 degrees from 0 to there, what's left to get to 180 would be 60 degrees. This is to be a 60-degree reference angle. And the reference angle is all we're really caring about. Because if we know our automatics, that's why it's important to know your automatics. 120 is in the 60-degree family, or pi over 3 family. In radians, it's 2 pi over 3. So it's really easy if you know the radians, because anything that has pi over 3 in its name is in the pi over 3 family and has the same numbers that show up here. The same numbers will show up in that row, except we got to remember sine is y, cosine's x, and we got to maybe attach a negative in front of the sum of these values. At 120 degrees, you're past the origin, or you're in the second quadrant. And in the second quadrant, the x values will be negative, the y values will be positive. So for the sine of 120, it's in the 60-degree family. We know the number, the value is going to be square root of 3 over 2. And since we're in the second quadrant, that's still going to be positive because y is positive in the second quadrant. We're above the x-axis. Cosine, the same value is going to be recorded, 1/2, but it's going to be negative because we're moving to the left, and to the left is negative in the x direction. Tangent is always a combination of these two things, and if one of them's positive, one's negative, the tangent will be negative. Tangent's negative in the second quadrant, so it's going to be negative square root of 3. And then for these, if the square root of 3 over 2, the reciprocal of that is 2 square roots of 3 over 3, well, we've got the same value here. You're going to see these same values show up over and over and over. The reciprocal of negative 1/2 is negative 2. If a number is negative, its reciprocal is negative, always. Negative square root of 3 becomes negative square root of 3 over 3. Okay? Let's skip down to row 10. 210 degrees is the same as 7 pi over 6. Sorry about the blotchy there. But 7 pi over 6 is equivalent to 210 degrees. Pi over 6 family. Look for the pi over 6 family here. These values show up again. However, 7 pi over 6, that's just past pi. That's in the third quadrant. And in the third quadrant, y is negative and x is negative. And then the tangent will end up being positive. So all I got to do is go back to the pi over 6 values here. Copy down the same value. It'll be negative though for x because we're moving, or sorry, for y because we're moving down. It'll be negative for x because we're moving to the left. But then the tangent value will still be positive. And then these numbers will be the same too. Again, though, if this was negative, the reciprocal is negative. Negative 2, negative 2 square roots of 3 over 3. And then this is positive square root of 3 still. If the tangent's positive, the cotangent's positive. Okay? We go to row 14, 5 pi over 3. That's the same as 300 degrees. And if it says pi over 3, it's in the pi over 3 family. We just use these same values here. Fourth quadrant, though. 300 degrees or 5 pi over 3 is in the fourth quadrant. So, in the fourth quadrant, sine will be negative, cosine will be positive, tangent will be negative. So, this will be negative square root of 3 over 2. It'll be a positive 1/2. And it'll be a negative square root of 3. Same numbers that show up in the pi over 3 row, but attaching the negatives depending on if y or x is positive or negative. And then the reciprocal of that is going to be negative 2 square roots of 3 over 3. The reciprocal of 2, or 1/2 is 2. The reciprocal of that is negative square root of 3 over 3. All right? So, rows 1 through 17 are all variations of that same idea. You're given the angle either in degrees or radians. You fill in the other one and fill in those values. Then you get to row 18, things change a little bit. Row 18, now you're given a number in the table. You're not given the angle. Now, for some of these, there might only be one angle that gives you a sine value of -1. For example, in row 18, there's only one angle here that's possible. But for some of these rows, there's more than one angle. Like there's more than one time around the unit circle when the cosine is positive 1/2. Try to squeeze both angles in here. I'll show you. We'll do row 21 together here. Okay? What we're given in row 21 The only thing we're given is that the cosecant of the angle theta is -2. Well, the cosecant is the reciprocal of the sine. So if the cosecant is -2, that means that the sine must be -1/2. Okay, now we have to ask ourselves, when is the sine of an angle -1/2? Well, if I know my automatics, I know the 1/2 occurs in the 30-degree family. So it's got to be 30-degree family. But the fact that it's negative and sine is y, this means we're below the origin. And the quadrants where we're below the origin are third and fourth quadrants. So the third quadrant angle, that is a pi/6 family, would be 210 degrees. And the fourth quadrant would also be negative. So this could be 210 or 330. We don't know which one, so we're going to write them both. In radians, that would be 7pi/6 and 11pi/6. Try to squeeze them both in that little space there. I know you got to write really small there. Now, the cosine of the angle. Well, if it's 210, that's going to be negative square root of 3/2. But if it's 330, it's going to be positive square root of 3/2, because that's to the right of the origin, and that's positive for x. So just do plus or minus square root of 3/2 in that case. I'll trust you know which one goes with which. The tangent, third quadrant, tangents are positive. Fourth quadrant, tangents are negative. So that's going to be plus or minus square root of 3/3. And then these last ones, you just flip the fractions over again. The secant is the reciprocal of the cosine. So if the cosine was a positive or negative, the secant will be a positive or negative, and the reciprocal of that is 2 square roots of 3/3. And the reciprocal of square root of 3/3 is the square root of 3, and it's plus or minus. Okay? So that's what you do when you have a value in the table, and that happens in rows 18 through 23, and then a couple other times. Row 29 it happens, and row 31 it happens. So you might have plus or minuses in there, you might have two angles involved. Two more things I got to show you, and I'll be done. I know it's a long video. Row 25, -210 degrees. What the heck does that mean? All that means, we typically measure counterclockwise. A positive angle, like 90 degrees, is up here. Here's 0, here's 90. You're going counterclockwise. The hands of a clock typically go this way. That's called clockwise. Counterclockwise, the other direction. So counterclockwise is a positive direction. If you have a negative angle, that just means you're going the other direction. Okay? So if the angle measure is a negative number, that means you're going clockwise. So when you see -210 degrees, first of all, that's equivalent to -7pi/6. All right? If this angle is negative in degrees, it's also negative in radians. So -210 is the same as -7pi/6. But for the rest of the table, all we really care about to get these values here, we have to figure out the terminal position of -210 degrees. And what I mean by that is if we start at 0 and we're counting -210 degrees, this would be -90, this would be -180, and then 30 degrees more. So -210 would be about there. What's the positive angle that would have the same terminal position, the same finishing point there as -210? Well, +150, 30 degrees short of 180. So +150 degrees would have the same terminal position as -210 degrees. So for the rest of the table, all you got to do is think of this as being a 150 degree angle. Okay? So the rest of this, is it going to be the same as +150 was? Well, +150 is in the pi/6 family, so these numbers are going to show up again. 150 degrees is above the origin, so that's positive for y, so it'll be a +1/2. It's to the left of the origin, so it'll be a negative square root of 3/2. And second quadrant is where this terminal position is. Second quadrant, same as 150. Tangents are negative, so it's going to be negative square root of 3/3. and then flip those over, you get 2, you get negative 2 square root of 3 over 3, and then you get negative square root of 3. All right, and this last example is number 26, 31 pi over 3. Oh my gosh, okay, well, typically we stay within 1 revolution of the unit circle, but some cases, you can have angles that are much bigger than that. 31 pi over 3 is more than 1 revolution of the unit circle. First of all, how many degrees is that? Well, every pi over 3 is equivalent to 60 degrees, so all we got to do, really, is multiply 31 times 60, okay? So 31 times 60 1860. So 1860 degrees would be the equivalent angle measure. All right. Now, how do we figure these out? Well, again, it just like the last one, it comes down to the terminal position. Every revolution around the unit circle is 360 degrees. So that's 360. How many times does 360 go into 1860? Well, okay, got to do a little math. You could divide 1860 by 360 and see it goes 5.166 times. What's that? Well, you know there's a fraction to decimal key here, the shift of the probability key. That says 5 1/6. Okay, 1/6. So 5, that means 5 full revolutions and 1/6 of another one. What's 1/6 of a revolution? 60 degrees. So it's the same as 60 degrees. Coterminal. Coterminal means it shares the end position with 60 degrees. So the rest of this table will be the same as it was at 60 degrees. Now, certainly at that point you could just look up here and copy these down, but it would be better if you challenge yourself, okay, and try to write them down without looking, and then compare your answers up there. 60 degrees, the sine of 60 is square root of 3 over 2, tangent is 1, or cosine is 1/2, and tangent is square root of 3 or square root of 3. And then if you flip these over, 2 square root of 3 over 3, 2, and square root of 3 over 3. Okay? So that should help you complete this table. Once you get it complete, send me a picture of it by way of email through Schoology, please, and I will give you the 2 points. Okay? Even if not everything's right. Hopefully mostly all of it will be right, and then I will show you the key online. Thanks.